And
Okay.
you'll have access to this afterwards. You know, if we cover any material you want to review, that's the way you can do it. So let me start with multiplying a binomial times a binomial.
Right.
Since this is really where factoring kind of begins. How do I do that?
They taught us like FOIL.
Okay, do it. Just do it for me.
You'd have x squared minus x minus 6.
Okay. Good. So, factoring is when you start with this and you have to figure out what the two linear factors were.
Right.
Okay? And that's much harder to do than multiplying these two together. But one thing you can see right off the bat is that this -6 that you produced can only be produced by a positive and a negative number being multiplied together. In other words, if this was x plus 2 times x plus 3, that would be a positive 6. If it was x minus 2 times x minus 3, that would be a positive 6.
Right.
Okay? So let's talk about factoring. Factoring is something you always want to do in an order of priorities. Okay? And the very first thing you want to look for is that. You know what that stands for?
The greatest common factors.
Okay? So if I have an expression such as factor the greatest common factor out of that.
2
Times what?
times x plus 2 squared.
X squared.
Oh, okay. X squared
In other words,
plus
here's
2.
what I'm doing. I'm dividing each of these terms by 2.
Right.
When I factor out a 2, you're correct. The greatest common factor is 2. But the way I get the rest of it is by dividing every term by 2. So the middle term is what?
X squared plus 2x plus 4.
Okay, great. Now let me change the problem slightly so that it becomes this. Now what's the greatest common factor?
2x.
And what's left?
X plus.
Now, when you're doing these, when you're factoring out a greatest common factor, the way I want you to do it in your head is that the moment you get this first term, stop, multiply those two together, and make sure you get that. Do they multiply to that?
No.
Then we've made a mistake. Better to catch it now than after we've done the whole thing.
Okay.
So try to catch your mistakes at every step of the way. So what is this? It's not x. What is it?
2x squared.
It's just x squared. In other words, remember, our greatest common factor was 2x. So
Right.
now we're dividing everything by 2x. So the rest of it?
Plus 2x plus 4.
Okay, cool. So that's really covers greatest common factor. Now, the next thing that you should look for, I'm going to list these and leave them up there, is what I call dopes. difference of perfect squares. Okay?
Mm.
The general format for difference of perfect squares is a squared minus b squared. Question is how does that factor? You know?
A plus b times a minus b.
I'm going to write it like this, and there's a reason. What you said is correct, and these can be written in either order. But let me ask you something. Was there anything on the test about difference of perfect cubes or sum of perfect cubes?
Yes.
Okay,
There
good.
was one of each.
If you're going to memorize those, then this is the way you should memorize this one. And I'll show you why. Okay? Now, let's give an example. X squared minus 4 would factor how?
X minus 2 times x plus 2.
Okay, good. Now, I'm going to erase that. It's clear you understand difference of perfect squares, but as long as we're talking about it, let's talk about difference of perfect. First of all, there is no sum of perfect squares. A squared plus b squared does not factor.
Right.
So, but there is a difference of perfect cubes and there is a sum of perfect cubes. And let's just talk about both of them at the same time, kind of. So, the reason I wanted you to put the negative first, do you know what this factors into? The middle one?
A squared, or
First factor is always linear. All three of them. And it's always the same sign as what you start with.
So then it's just a minus b cubed.
No,
basically.
This factor is necessarily going to be a quadratic because when you multiply a linear times a quadratic, you get a cubic. But the middle term is the opposite sign of the first term. This is AB, and this is always positive. And it's also square. And then the sum of perfect cubes, the first linear term is the same sign as what you're starting with. And the second term is just like above, only the middle term is the opposite sign. And that's the way to memorize it. Because it's real easy. In all three cases, the first term is linear and the same sign as what you start with. And in all three cases, the second term is different sign than what you start with. Okay? Now, for the moment, let's not deal with the cubes. We're going to talk more about factoring before we get to those, but definitely difference of perfect squares. When you learn algebra, usually you learn through the difference of perfect squares, and then you learn all about factoring, and then more stuff. And then later you come back to difference of perfect cubes and sum of perfect cubes. So let's try that. So the order that I want you to consider when you go to factor something is 1, is there a greatest common factor? 2, is it difference of perfect squares? And if it's neither of those, if you can't do either of those, then this is what I call quadratic factoring. And this is what gives most people an awful lot of trouble. And so we're going to spend a lot of time on quadratic factoring. Unless you're really, really good at it, then the only way we can get you really, really good at it is to practice.
Right.
Okay? So let's start with a very simple one. Now, this is a quadratic. It's got an x squared term, it's got an x term, and it's got a constant. Even if I erase the plus 10, it would still be a quadratic, but you could factor it using greatest common factor, which would be a lot easier. You'll
Right.
notice that when you have all three, when you have an x squared and an x and a number, you can't use greatest common factor usually, and you can't use dopes. So you're stuck with factoring it the normal way they show you. And the reason I call this a simple one isn't because it's simple, but because the coefficient of the x squared is 1. When the coefficient of the x squared is a 1, then it is a very simple factoring method. And I can teach it to you real quickly. Okay, I'm going to write the steps. First step, separate the x's. How do you do that?
You put 1 on the left side of each parenthesis just to start.
And again, if I was multiplying these back together again, I know that this x squared term only comes from this term on the left multiplied the f of FOIL, right?
Right.
So I know I've done it correctly. If one of these said 2x and the other said x, then I've made a mistake because they don't multiply together back to x squared. Okay. Number 2, determine both signs. Now, I'm not sure this is necessarily the way you learned it. I'm one of the few people that maybe teach it this way, but I'm absolutely convinced that it's the simplest way. I have trouble teaching factoring to students that learned it a different way because I don't know how you learned it. There's like 4 different methods. So, and I don't know all of them. And the only thing I know about some of them is they're extremely confusing, complicated, difficult to remember, whereas my method is pretty simple, especially if you're dealing with a simple quadratic. What do both signs have to be in this case?
Positive.
Yeah, in other words, I could not produce a positive 10 unless they both were the same. So I know it's either negative, negative, or positive, positive. And to know which, look to the sign on the middle term. Since that's a positive, they're both positive. Now, third step, also very easy. Factors of the constant, plus 10, actually just 10, that add if it's a plus sign in front, or subtract if it's a negative sign in front of the constant, to the middle term. Well, what is that in this case?
It can only be 2 and 5.
Yeah, and it doesn't matter whether I put the 2 there and the 5 there, or the 5 there and the 2 there, because both produce the same result. Okay? Now, let's talk about checking it. On these simple ones, you're probably good enough that you're not going to need to check them. But I want to go over the checking procedure because it's vital to the process when you're trying to do the harder ones.
All right.
Okay? The checking process. I do not have to check the x squared term. I know that's correct. I do not have to check the plus 10. I know that's correct. The only term that I might be off on is that middle term. And the middle term always comes from the O and the I of FOIL. The inside or the outside and the inside. So multiply those together. Add them together. That's also what happens to produce that middle term. That's correct. We've done it correctly. That's all you need to check.
Great.
Okay. All right. Let's go a notch higher in difficulty. I'm going to put a negative sign in front of the constant. This is only 1 step harder. Instead of 3 steps, it's 4 steps. But it's exactly the same 4 steps every time. Let's see, what do I want here? Let's try a negative 3x. Okay, so first step.
So separate the x's.
Second step.
Both signs are negative.
Nope.
Or nope. One sign is positive, one sign is negative.
What you meant was both signs are opposite one another.
Both signs are opposite.
Because that's the only way you can produce a minus 10.
Right.
Okay, and it doesn't matter if I put plus minus or minus plus. It's going to result in the same thing. So in these simple ones, again, simple meaning a 1 is in front of the x squared, then these 3 and 4 step problems are all you need. That's it. You can use it every single time. Now, step 3 again. What? Verbalize it out loud.
The factors of the constant
Factors of 10 that do
right.
what?
The produce.
Is it add or subtract?
Add.
No, in this case it's subtract because of that right there.
All right.
So whatever that sign is that's in front of the 10, that's what these factors have to do. In this case, it's going to be they have to subtract to what?
Negative 3x.
Actually, just 3. Don't consider the sign and don't consider the x. You're only looking at the coefficient. And in this case, it's just 3. It's not even negative 3. Not yet. Okay? So what factors of 10 subtract to 3?
5 and 2.
Okay. Now there is a fourth step on these. Put the largest factor, the 5, with the sign of the middle term. So the 5 goes where?
Next to the subtraction sign.
Yeah. So, right there, if you can learn those 4 steps, that will get you through 75% of the factoring problems you're going to have to do.
Right.
The biggest mistake that I see students making when they come across a quadratic that needs factoring is they try to do the whole thing in one bite. They do. They're off and running. I give them a quadratic and it's x plus 5 times x minus 3. No. And then they back up and they try to do the whole thing in once again. Don't do them that way. Do them step by step. There's just no way you can make a mistake. So let me give you some to practice on, because this alone, these 4 steps, even though these are elementary quadratics, it doesn't hurt to be perfect on these. And you'll get perfect on them. They're not that hard. I'm just going to make up a bunch of them. Every one of them is going to have a 1 as the coefficient of x squared. And I'm going to have to think for a moment. Okay. Always start them this way. Step 1.
Separate the x's.
Go ahead and give me what that is, because sometimes when we get to harder quadratics, there's going to be multiple ways to separate those x's. In other words, if I had a 2 in front of there, then it's going to be 2x times x.
Right.
So when you say separate the x's, separate them for me.
So x minus 4.
No, don't do it all in one chunk. I want to see you do it in steps.
Okay. Now, the first sign is going to be a negative.
Both signs. Both signs at once. There's a reason why I want you to do both signs at the same time.
The first sign will be opposite.
In other words, the signs will be opposite.
The signs will be opposite.
That's step 2. That's all you have to do. And it doesn't matter if you write it plus minus or minus plus. Step 3.
The factors of 12 are 3 and 4.
What do they need to do? Do they need to add or subtract to what?
You need to subtract.
To what?
To 1.
Yeah, not to x, but to the coefficient of x. So you're right. 3 and 4 are it. Now, use step 4. Where's the 3 go? Where's the 4 go?
The 3 goes with the first x, next to the positive sign.
Yeah, because the larger of the factor goes with the sign of the middle term. All right, I'm going to erase this. And I'm still going to give you more of them until I feel like you know those, they're down pat. Okay? Do it step by step. I don't want a final answer, even if you can do it in your head.
Separate the x's, and both the signs are both opposite. Signs.
No, they're not. If they were opposite, this would be a negative 25.
Because the first
Don't figure out the first sign. Figure out both signs. And the way you figure out both signs is by looking at the sign on the constant. That tells you both signs are the same. Now we have to know whether is it negative negative or is it positive positive. And we look at the sign on the middle term. So it has to be negative negative. Third step.
What are the factors of 25
that
subtract to negative 10?
No, that add.
Add to negative 10.
Add to just 10. You don't even need to consider the sign on the middle term.
All right.
In other words, it's factors of 25 that add to 10. Well, that's 5 and 5, right? And it doesn't matter which way I do it. There's my answer. So it's easy peasy. It's just doing it step by step. Notice in this case, I didn't even need the fourth step. The only time you need that fourth step is if there's a negative sign in front of the constant. Thinking. Still first level. We're always first level until you get a coefficient other than 1 in front of the x squared.
Right.
X and x.
X and x, and the signs are the same.
Nope.
Yeah, the one's positive and one's negative.
That means the signs are opposite.
Opposite.
Yeah, they're opposite one another. The same would be negative negative or positive positive.
Right.
Now, what's the third step?
The factors of 100 that subtract to 15 are 5 and 20.
Go ahead.
The factors of 100 that subtract to 15 are 5 and 20.
Okay. Now you have the fourth step to figure out where the 5 goes, where the 20 goes.
The 5 goes next to the positive sign, or addition sign.
Perfect. And if I wasn't 100% sure, if I was wagering my life on it, I would want to at least check the inside and the outside terms. That's the inside. This is the outside. Add them together. You get the middle term that we're looking at right there. Okay. All right. Let's go up a notch. I'm going to stick a 2 in front of that. Stick a 5 there. And that there. Now, this, you use the same first 2 steps. But after that, you got to throw steps 3 and 4 out.
Right.
They don't apply. So what's the first step again?
Separate 2x and x.
Okay. Second step?
The factors of 5
No, that's the
or
third step. Second step, everybody leaves it out. It's figure out both signs.
the signs are both positive. The signs are the same.
Well, they are the same to begin with, but then because the middle term is a positive, that narrows it down. They're both positive. Okay.
Right.
Now, you cannot, like I said, you cannot say factors of 5 that add to 11 or factors of 5 that subtract 11. You can't use those rules. That's why these are harder quadratics to solve. However, usually when they give you problems like this, they don't give you a whole lot of different factors for the constant. What are the only factors of 5?
1 and 5.
Yeah. Now, at this point in time, this really kind of becomes a trial and error process. Especially simple ones like this, because I only have 2 choices. I can either put the 5 on the left side and the 1 on the right, or vice versa. Well, let's say I just didn't want to think about it at all, so I just pick one. Does that give me the correct middle term? What middle term does this give me?
7x.
Okay, so that's not right. So let's switch it and put the 1 there and the 5 over there. What middle term does that give me?
11x.
That's the answer. Okay, so you kind of have to use trial and error. Now I gave you a pretty simple second level one. Let's make it slightly harder. And I got to think about it for a minute because, let's see, what do I want? I want right there. I think, hold on a second. Yeah, okay. Step 1.
Separate 2x and x. And the signs are opposite.
Okay, now, here's where we deviate. The signs are opposite, but in this particular case, plus minus is not going to be the same as minus plus.
Right.
So I have to allow for both. And the way I do it is this way. I don't know yet which is I'm going to use. Okay, I do know the third step has to be factors of 10, right?
Right.
So let's list them all. And I said it's a trial and error process. And the first trial you always want to guess is the 2 closest factors. I'm never going to start off by trying 10 and 1. I'm always going to start off by trying 5 and 2. And I don't know that it necessarily, I don't have to give it a lot of thought to try to figure out what's correct. I'm just going to randomly start trying it.
Right.
Okay? What middle term does that produce?
So 3x.
No, it produces 1x. Remember, it would be 5 times x plus minus 2 times 2x.
Right.
Okay? Well, plus x not only is the wrong sign of the middle term, but it's not the correct number either. If we had the correct number, then we could just move these numbers down to the next sign below it, and we would have the correct sign. So the fact that plus 5 and minus 2 does not work and does not even produce the correct number means I don't even have to worry about putting the 5 with the negative sign and the 2 with the positive. Next thing I'm going to do is to switch the numbers. Okay? Now, what middle term does that produce? Yeah, my apologies. I meant that to be 8. I just wasn't doing my advanced math correctly. That produces minus 8, right?
Right.
In other words, if I do, and this is where, in order to figure the problem out, you kind of have to use the double smiley face, or at least it's as good a method as any, to make sure that you've got the right middle term. Minus 8x, okay? Now, what I was referring to was if that came out to be the right number, 8, but the wrong sign, then all I would do is move these numbers down. In other words, I would move that to there, I would move the 5 down to there, and then I know that'll be plus 8. Because all it does is change the sign of that middle term, doesn't change the number. And that's very helpful when you're doing a trial and error process, because there are 2 sets of factors and there's 4 combinations for each. So there's actually 8 combinations here that I might have to try before I find the correct one. So when I can try one and it actually eliminates another one at the same time, that's very valuable. In other words, I know that worst case scenario is I'm only going to have to try 4 combinations. And it is trial and error. Now, this is where some of the methods they teach, like the California method or the diamond method, this is where they become more useful, but they're still very complicated and, in my opinion, not necessary, because it's not that hard to do the trial and error. And ultimately, each of those methods uses a trial and error as part of its process. So it doesn't eliminate the need to do trial and error. Okay? Now, I think you can begin to see why these could get really tough. And let me give you an example of what might be tough. If I put a 6 there and a 12 there, I don't even know what this might be. I'm just going to leave that blank for a moment. I'll put a minus sign in front of it. And let me experiment in my head a little bit. I'm still thinking. I think 21 is what I think that'll work. But you can begin to see why this is a lot harder, right?
Right.
First of all, what's step 1?
Separate the x's.
Do it.
2x and 3x.
Doesn't have to be that. It could be 6x times x. That's why it's so hard. In other words, all of a sudden we've opened the door to a lot more possibilities.
Right.
And factors of 12, you got 12 and 1, 6 and 2, 4 and 3. All of a sudden we have a gigantically hard problem, even by trial and error. Okay, so the suggestion is still the same. Choose the factors that are closest together. Always start with those. Don't start with 6x times x.
Right.
Signs have to be opposite, but it matters because 3 is not the same as 2, so I got to allow for both plus minus or minus plus. Now, factors of 12, again, start with choosing the 2 that are closest together. They may not be correct, but that's where we're going to start. Okay? And not even close. Even if I put the 4 multiplied by the 3 and the 3 over there, No way am I getting up to 21, right? You can see that immediately.
Right.
And certainly switching the 4 and the 3 doesn't improve things. So 4 and 3 don't work. So let's try 6 and 2. Now, again, I can see that I got to get all the way to 21. So I wouldn't mind having the 6 multiplied by the 3, which makes the 2 multiplied by that. That gives me minus 18 plus 4. That gives me minus 14. That doesn't work.
Right.
There's no way I can get any higher by moving these two numbers relative to one another. So 6 and 2 doesn't work. Well, I gotta try 12 and 1. Who knows? Maybe 12 and 1 works. And if I have the 12, multiply that. Whoops, didn't write that correctly. I'm going to do it the wrong way first. Now, what middle term does that produce?
Minus 18x.
No, that's plus 24.
21x.
But it's plus 21x, right?
Oh, so you flip the signs.
Yeah, so I got the right number, wrong sign, so that's an easy fix. I move the 12 down to that one, and I move the 1 down to that one. And now if I do the same inside and outside, I get a minus 24x, a plus 3x, which gives me a minus 21x. I got the right answer. Now, it's possible that it could have been even harder still, that we would have had to go back to the beginning and split up the x's as a 6x to an x. So these higher level quadratics can be very lengthy problems.
Does it also work that I got 2x plus 12 times 3x minus 1?
No, I don't. There's not going to be multiple solutions. Let me show you why. 2x plus 12 times 3x minus 1 gives you a middle term of plus 36x, gives you an outside term of minus 2x, gives you a total middle term of plus 34x. That's not our... Okay. So this checking process, what I call the double smiley faces, is absolutely an integral part in solving these. It's not just the way to check once you get done. It's the way to solve them. You have to use that as part of the process.
Okay.
Now, in general, they're not going to give you something this difficult just because it has so many different possible choices. And no matter how you do your factoring, it comes down to a trial and error. And a lot of math does. When you get into higher Algebra 3 math, there's some processes that are just trial and error. And sometimes you have to try 12 different numbers. All right, let's talk about this. Factor that.
Okay. Separate the x's into 2x and x.
Okay. Actually, that's not the first step. The first step is always number 1.
Oh, greatest common factor.
Yeah, you'll see why. Why you always want to do that first. Because it turns it into a simple quadratic once you do that. In other words, if I factor out a 2, what I'm left with is x squared minus 7x plus 10. Well, this was the very first one we did. That one's a piece of cake. X, both signs are minus, factors are 5 and 2. And that's your answer. So always look for that greatest common factor because that can change it from a hard quadratic problem to an easy one. Good. And it actually would have been relatively hard because there's quite a few factors of 20. that we would have had to consider. So yeah, never forget to take that greatest common factor out. And another way you'll see problems like that is, or similar to that, is where they put a variable in all three. In other words, if you see a cubic, in general, they have not taught you how to factor cubics yet. They may have taught you how to factor difference of cubes and sum of cubes. But a standard cubic equation, they may have taught you how to group it, but that's about it. I doubt that they have taught you. Hold on one second, Nathan. My TV just went off. Let me go turn it down. Thought I had turned it off, but I guess I just put it on pause, and when it's on pause, it automatically comes off pause after an hour.
Yeah, can't wait forever.
All right, so sometimes you'll see a problem like this. Now, that's a cubic. You don't know how to handle cubics, but when you check and see if its greatest common factor turns into x times a quadratic. And we know how to handle the quadratic. We can't forget the x. Now, if I said all of that was equal to 0, what would the solutions be?
-5, 2, and 0.
-5, -2.
-5, -2.
And 0. In other words, the way you get the solutions is to set all three factors equal to 0. You set that equal to 0, you set this one equal to 0, and you set this one equal to 0. And that gives you x equal -5, x equal -2. Okay? A lot of people forget this one right there, but you didn't, so that's good. All right.
They had questions like that, and then it would be like divided by x plus 2 or something like that.
Let's talk about long division. We're not anywhere near done with factoring, but we're close. Before we get into long division,
All right.
what if that was the problem? Can you factor it?
No.
Are there factors of 9 that add to 7? No, there aren't.
Right.
So what would you do with this? Quadratic formula. If the first three methods fail, you go to the quadratic formula.
Oh, yeah.
It is what? This is something they're going to expect you to have memorized.
Yeah, I don't know. I don't remember if they had that on the test because they said they don't use calculators there.
Well, you don't really need a calculator. I'll show you why. Let's just go through one. I'm pretty sure you're going to be required to know this. I just have never met an algebra student that isn't expected to know the quadratic formula.
Right.
They even teach you a song to memorize,
They do.
much like they teach the ABCs to students. There's the quadratic formula, and what A, B, and C are the coefficients of that quadratic. So
Right.
A is 1, B is +7, and C is +9.
Okay.
All right, so now plug everything in. What's minus b?
Oh, -7.
Plus or minus the square root. What's b squared?
The square root.
What's b? Just plug
That.
it in. Before you do the calculation, plug everything in. Don't do it all in one step. I mean, I know you're smart with math, and I really do mean that. I can tell you can do a lot of this stuff in your head, but it just induces mistakes.
All right. 49 minus
Especially
4.
with using the quadratic formula. 4 times 1 times 9. All over 2 times 1. Now, you'll see why I said that you don't need a calculator here at all. This is not to be turned into a decimal. This answer is -7 plus or minus the square root. Well, 49 minus 36 is 13. All divided by 2. There's your answer right there. That's the proper answer. It's not turning that into a decimal. Notice no calculator was required here. But you'll notice something else about the answer is I've got irrational numbers right there. Square root of any number that's not a perfect square is going to be irrational. So whenever you find a quadratic that does not factor, there still are answers for x. In other words, if I said that's all equal to 0, well then x is equal to these two answers right here on the left. So there's always an answer for x. Sometimes it can be imaginary. Did they have any questions on the test about imaginary numbers?
They didn't.
Do or do not?
They did not actually.
Did not. Good. That's just one area we won't have to cover. Okay. Sometimes, though, if this b squared minus 4ac, if that is a negative number, then you're going to be taking the square root of a negative number, and that's the only answers you get are imaginary numbers. So you kind of have to learn imaginary numbers not too long after quadratics, because they are a part of solutions for quadratics sometimes. But if they haven't taught them to you, we will try to ignore them for the moment.
No, I know the imaginary numbers. The only thing on that I really have trouble with is when there's imaginary numbers in finding the square root or something like that.
Well, let's talk about that. If I said x squared equals -4, and I have to answer, well, what is x equal to? Well, I take the square root of both sides. No, not 2. 2 times 2 is +4.
Oh, 2i.
Not -2, because -2 times -2 is +4. So there are no two real numbers that multiply together to -4. So you get an imaginary number, and you actually get plus or minus 2i. I being the square root of -1.
Okay.
Okay, it's just, they call it imaginary for the reasons you would suspect. It's not real, it is imaginary. It's strictly a tool that mathematicians have made up in order to facilitate higher math. That's the only reason that they invented it. But it turns out to be quite useful in higher math. This concept of the square root of -1 is, we'll call it I. Okay. That's been about an hour, I believe.
Right. This is a good place to stop.
Yeah, this is a good place to stop. Now, I'm going to recommend that we finish all of these online as long as you're happy with online.
Yeah.
I haven't run into too many students that don't like online. They just do. it pretty much, you can see it differs almost nothing from being in person. The only difference is you're not looking at my face and I'm not looking at your face. But everything
Well, this
else is the
go-to
same.
meeting this go-to meeting app is just one of the coolest things I've ever seen.
It is. And I have recorded this and I will post that. Do I have let me see if I have a email address for somebody. Do I have an email address? I don't. You want to give me an email address and I will
Yeah,
be able to send you a copy of the recording.
right. You can send it to the one on my grandma's computer, which I'll give you.
Okay.
It's Diana, lowercase,
Is it with an E or an A?
with an A.
Diana, like that?
Yeah.
Okay.
At Heidelberg,
Oh,
HeidelBerg.
hold on. I'm sorry. HEIDELBERG,
DEL.
like in Heidelberg, Germany, right?
Right.
I used to live there, actually.
Wow.
Uh-huh.
And that's where my grandma's from.
Wow. Yeah, no, my dad was in the military and I spent time in Mannheim and Heidelberg when I was in the
Wow.
summers of my college years.
Oh, those would be some great years.
Yeah, they were back then. So that's at what?
Hyphen antiques.
Oh,
The at is after Diana.
oh, the at is there. So
Right.
it's Diana at Heidelberg-Antiques.
Yes.
And is my spelling correct on antiques? I think it is.
Yes, it is.
Okay. So I will send a link as soon as it's processed to this email address and show you how it'll just be a link that if you click on, you'll find a YouTube file that is a recording of our session.
All right. Thank you.
Okay. All right, Nathan. Yeah, I think this probably is going to work the best just because it's the most flexible. One thing
Right.
you don't have a lot when you meet in person is a lot of flexibility. You got to reserve the rooms in advance and all kinds of stuff. But online, I don't care. If you're a half hour late, it doesn't bother me. If you
Right.
change it by 2 hours, it doesn't bother me as long as I'm not doing anything at a different time. But so, yeah, and you can schedule as much as you want. If you want to do 2 hours tomorrow, do an hour in the morning and an hour in the afternoon. Don't do 2 hours
That,
at once.
yeah, that would be great.
That's
We'll
just
do
too
that.
much math. It burns one out. So
Yeah.
the best way is, I know you want to take this test again early next week, so we
Right.
don't have an unlimited amount of time, but I'm pretty convinced that if you can get 2 or 3 more hours in, we'll cover an awful lot, allowing you to pass that thing.
Right. Thank you. I was thinking kind of maybe an hour or two a day, maybe until Monday or Tuesday.
Well, that's not much. Tomorrow's Sunday, so try to do 2 hours tomorrow.
Okay.
And if you know when you want to do the first one, you can tell me now and I'll put you on the schedule.
How early works for you?
9?
What about 10? Is that okay?
Yeah, that's fine.
All right. Sounds good.
10 o'clock, I will call whose number should I call? Your home number or your grandparents' home number?
Yes. Do you have that?
303-282-6615?
Yeah, that's it.
Okay. That's what I will call tomorrow at 10 a.m. and we'll do another hour then.
Thank you.
You're welcome very much. Have a good one, Nathan. Bye. So to close out of GoToMeeting, just click in the upper right.
Okay.
Okay. There you go.